breaks it down to the bone gristle. Ill speaking, scud missile, heat seeking. Johnny blazing, nightmares like Wes Craven. Niggas gunning.
Hi guys, my name is Nako Nakatsuka. I'm a 4th year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now let me give you examples of how we write out these electron configurations. So let's take boron right here. It's element number 5, and so it has 5 electrons. So just by following this, we know that we go 1s1, 1s2, 2s1, 2s2, and then 2p1. So for boron, let me do it right here, the electron configuration would be 1s2, 2s2, and then 2p1. So now when we go to elements that are further down the periodic table, it would take forever to write out everything. For example, if it was gallium right here, number 31, you don't want to write 1s2, 2s2, 2p6, 3s2, etc., etc. And so what you can do is abbreviate it by using the noble gas that is the closest to it, that's before it. And so in the case of gallium, right here, the closest noble gas that is before it is argon, right here. So how would we write gallium? We would write Ar, and then what follows Ar? We have 4s2, and then we have 3d10, and then this guy right here is 4p1. And so I again just followed this table. But now I want to tell you a few rules and exceptions. And so first of all, I wanted to mention that the 4s orbital right here is occupied before the 3d orbitals, although the principal quantum number is 4, which is higher in energy than n equals 3, right? And so in this case, let's take calcium, for example. Calcium would be, I'm going to abbreviate it again by using argon, which is the one right before, and then it's going to be 4s2, instead of it going into the d shell first. But once 4s orbitals are filled and electrons enter 3d orbitals, so around here, then the 3d orbitals become lower in energy than the 4s. So an example of that is, let's look at scandium. Where is scandium? Let's see. There it is. Okay, so element number 21, scandium. So in this case, how we write scandium? Usually, we would think it would be Ar, the abbreviation, then 4s2 and 3d1, right? Because that's how the periodic table is drawing it, as I did for gallium before. But as I said before, once the 4s orbital is filled and there's electrons in the d orbital, then this orbital becomes lower in energy. Thus, this would be written as argon 3d1 4s2 instead of this. So this is wrong. So in this case, the 3d1 represents the core electrons, and the 4s2 represents the valence electrons. So there's 2 exceptions to this rule. So I'm going to write it right here. 2 exceptions. And these you're just going to have to memorize since they're just outliers. So the reason why we have 2 exceptions is because half full D5 and full D10 subshells have lower energy. Let's look at why that is. So if we look at the d orbital, we have 5 orbitals, right? And so when you have D5, because of Hund's rule, you would put the electrons in parallel to one another. And so this is quite a stable configuration. The same can be said for D10. You would have pairing of electrons after you do the first 5. And again, this is a stable configuration. They have lower energy. And so the first exception is chromium. In the case of chromium, when we abbreviate it, we actually write 3d5, and then 4s1. In the case of copper, it's going to be argon, 3d10, 4s1. So looking at it simply, we would have thought that we would have 2 electrons in the 4s for both, right? But basically they pop up one of the electrons into the d orbital for here as well, in order to make it a more stable configuration. So these two are the exception to the usual rule that I talked about before. So period 5 shows the exact same trend as what we just talked about. 4d orbitals are lower in energy than the 5s orbital after 2 electrons have filled the 5s orbital.
About the flowing PZ afro, to Italian stallion, chinky eye and snot nose. From my naps to the bunion on my big toe, I keeps it moving. Know just what